As you will have seen, I have not yet returned your assignment. This morning, I just didn't have time to go through all of them. But I did kind of look through real quick through the PDFs, and I didn't see anything that was, any consistent issues. There were a couple people who missed a little piece or something, but nothing serious. So I think we're good there. We'll do, of course, some more practicing today. But then pretty soon we're going to be able to switch over to the project, which is going to be awesome. Just a reminder again, so next week on Tuesday, we will start having in-person face-to-face classes again. Now, on that Tuesday morning, I might be not sure if I'm going to be 100% on time, to be quite honest. I have a little bit of a strange flight, so I will let you know by email if I'm late, but nonetheless, it's going to be in person. All right, so with that, I think we will continue on our quest to understand the Inventor better. So we've talked a lot about the 2D sketching, and then we started talking about, I would say probably the most important features on the 3D models as well. And today we're going to continue with those 3D models. There's one really important thing, and then there's a couple things that may or may not become important for you guys as you go along. Now, the thing that's really going to be important is what we call work features over here, and especially the planes and the axes. The points, not so much. I don't think I've ever used a personalized or a customized coordinate system, so I'm not going to talk about this. But we're going to talk about planes, and we're going to go axes. And to do that, I think we're just going to start creating ourselves another nice little block here. 10 by 12, won't matter. Say okay, and we'll extrude it. And it's fine. There we go. Right. So now if we wanted to do anything else, we would click on any of these surfaces and we could draw something else and we'd be good. Right. But now what happens if we want to draw something that's maybe not straight on the surface, right? Maybe it's offset from the surface. Maybe it's on a surface that we don't have access to. Maybe it's angled or something. So to do that, we can use these work planes right here. If we open them up, you'll see there's a whole bunch of different ones that you can create. Now, we're not going to go through all of them, but we're going to look at the main ones. The first one is just offset from an existing plane. All right, so you can choose any of the planes. Not sure why it shows that one right there. Maybe I had it clicked already. Right, so you can choose any plane that you want to, even the ones that you can't see. A little kind of tricky to get to, though. You can also go in and create something that's parallel to any of the main origin planes. So we do it if we take this one, for instance, right, we click on it, and then it tells us the positive direction is pointing outward in this case. We say maybe we want to have an offset of 5 millimeters, right? And so then I could go and do just like I did before. I can start drawing on this one. You have to be a little careful because if you just click in the middle of it, it's not going to react. You have to kind of click on an edge. And I can do a new sketch, and maybe I'll just do a random circle. Now I can extrude that out, or maybe I want to connect it to it or something, right? So now I would have my little knob on there. Now, of course, I could have started drawing on this one going out, but this is just kind of an example. What else can we do? So that was just the offset. Let's see what else. Let's get ourselves, let's do a quick one maybe on this one. We'll sketch on here just because we need a point. So let's just drop a point on there somewhere and say finish. And now I could say go in here, parallel, add to a plane and through a point, right? So maybe I want to have something that's parallel to this and goes right through there. All right, who knows? Maybe I want to cut this block up to there, right? So I could, if we flip around this, could do a drawing, or even do a drawing Let's do a sketch here, some rectangle, and now I can say extrude inward, but instead of giving it a distance, I can give it a plane, right? So I can say extrude to that plane, and would cut into there, right? So you can see it didn't cut all the way through, just cut to that one plane. Right, so that was parallel to a point. Then there's the midway point that comes handy very often, especially when you want to mirror something, right? So you could do, I want to have something that's mid between this one and that one, so I can do this, and then that, and you can see created that extra plane. You can see all of these planes popping up over here in our model browser. Just like everything else, right? You could rename them if you wanted this. We say that's the halfway or something like that, right? Make it easier to find if you're going to need it over and over. And also what we can do is if we don't need them anymore, well, if we delete them, then it's a little tricky if you have something based on it, but at the very least we can turn them off so we don't see them anymore. All right, what else do we have from planes? Mid-plane through a torus I don't use very much. This one comes up very often, right? This is an angle to a plane around an edge. And so let's say I want to have something that is at an angle here, right? Kind of goes sideways upward. Well, what I could do is I could choose any of these planes, like with this one, and then the next one I choose is any kind of edge. Then you can see that I then get this plane that I can play with. I can move it just with the mouse, or I can put the numbers in there. Let's say we want to have that 60 degrees, right? And then I could draw on this one, do a plane, and I don't know, draw another tube on there, and then I could say extrude that one, and I want to extrude it until it gets to there, and now I get kind of an angled thing working on there. All right, so that's going to be very helpful whenever we need anything that is at an angle. And we'll definitely practice that one. Another way to get an angled one is going through 3 points, right? If you remember your math classes in 3D geometry, at some point you learned that a plane is defined by 3 points, right? So I can say maybe this point and that point and that point, and I get that plane. Right? Pretty straightforward. Right? That could be very helpful for one of the examples that we're going to work on later. What else? All right, then the actually last ones that I really want to do are related to these curved surfaces, right? Remember that we can't draw on a curved surface. You know, let's get ourselves a fresh one here. This is getting too crowded. Let's create another one. Let's say we draw ourselves a nice cylinder. Like that, and now let's say we want to drill a hole through the cylinder. All right, not top to bottom, but like through the side, right? So we said when we wanted to drill a hole, right, one way we could do it was the hole command, the other one was to kind of do a sketch and then extrude that hole through. Now, how about if we want to do it on the side, right? We can't sketch on the side, right? Those surfaces we can't sketch on. So what we can do is we can create basically a plane that's perpendicular, or that's tangential to the surface. But to do that, we need to do a sketch on here to create a plane, and to create a point. We need a point that's all the way at the edge here. Put that in. See, now I see a little point. And now we can say we want to get a plane that is tangent to surface through a point. And it needs to be, well, we can create the point, and there we have the surface. Right, so now I can say, well, I'm going to draw on the surface, do a new sketch, Let's do this one, just to mix it up a little bit. Like this, and now you can see it's not, can't zoom in close enough for that, right? But this would not be in there. But if we do a cut, and do that one, cut it all the way through, and then we can see that we can cut ourselves a hole through there. Right, and now you can see if we zoom in a little bit, right, that this is, it's not flat, right? Because of course the outer edges got cut in a little farther than the rest. All right, so that's going to be really important whenever we are adding something to it, right? We could do the same thing where instead of cutting a hole, we could add, like, you know, something on it if we wanted to. Right, so we can do new sketch, and you know, you don't have to be within this yellow area, right? The surface extends just like everything else extends to infinity.
Professor.
Yeah.
But what would happen if we want the hole to have like the curvature of the cylinder?
It has.
Is that you said that in the
If you
edges
look,
it
if you
was...
look in, if you look from the top, it is perfectly round.
Oh, okay. Then why in the side does it look weird?
Well, because on the side you're looking past this direction, right? If you're taking something that's curved and you cut a hole in it, right? Then if we scroll this down just a little bit.
Okay, yeah. What we're looking at is the edge of
If we're
the
looking,
other side.
right,
Okay.
if we're looking down, we're seeing this one. We can already see that this edge and that edge are further in this direction than what the center would be.
Okay, yeah, perfect. I got it.
That's
Sorry. Thank you.
no, definitely. But let's get back to this one. Let's extrude this one as well. Now let's this one do a little bit in two different directions. Let's choose this one. That can be something small. Ooh, that's not the one I want. That's small. This can be, let's do 5 and 2. Right, and then we can see that it connects in. You can actually see if we click on this, right, this is no longer a circle. This is some kind of other shape. Like, it's not even an oval anymore. It's kind of looks almost like an egg shape, right? So you get something that is, because it's on this round surface. So these planes can be, again, like, there's a lot of things that you'll do, especially once you get to the project, where you can't get around using these kind of planes. Very important. Now, when you're done using the planes and you're ready to do your export to PDF or something, make sure that you turn off the visibility for all of these. We don't want to have them floating around. Also, if you have extra sketches, right? So the sketch right here was not used by anything. I just needed it to have that point there. So I would turn that off as well. We don't want to have any extra stuff because it kind of distracts from what we're doing. Questions about planes?
Well, I have one quick question.
Yeah.
If they can turn off the visibility of like the whole figure, because I mean,
Yes.
let's say that we're working on a plane that is like at the middle of the piece, and sometimes it like sort of bothers.
Yes, you can, but you can only do it for things. You can only do it for certain things, right? So if I wanted to, my last one right here, for instance, right? I can go in, I can right click on this, and there's somewhere it says suppress feature. Now, if I click that, it will pretend it's not there. Now, the problem with this is that it works backwards. Unsuppress this. If I go ahead and say I can suppress this one without a problem, not gonna, or at least should be able to. All right, makes no difference, just I can't see it anymore. But if I were to suppress this big one, then it will automatically suppress all the follow-ups as well. Right, so that makes it a little bit difficult to use.
I think there was also like a sort of view in which there were like construction
I don't know.
It's not necessarily like disappears the whole thing, but it only left like construction. You don't know.
It's not something I've used, but something in here maybe. Feature appearance. Huh, I'd have to look. I don't know. I've never run into this. But if you remind me, I'll go back and check.
Okay, thank you.
Yeah. Other questions? All right, if there are no other questions, then let's talk about axes 2 a little bit. And then we'll do some example, or we'll do some other stuff before we get to our examples. So axes, very similar to the planes, right? I can create all these extra axes. But for this one, actually, let's go back to this one with straight edges. So it gives us a couple more options. So I can create these extra lines, and we'll see, for instance, the coil command that we're going to use later needs that, for instance. So I can create just basically take any kind of line, let's take this one, and create this extra work axis out of it. Right, that's the easiest one. Oops, that's the plane. I can do parallel and through a point. Right, so I can say I want to be parallel to this line, and I want it to go through that point. Right. In this case, there's not a whole lot of points here, so it's not all that interesting. But you'll see once you play with it how important it can be. I can have through 2 points, right? So I can have something that goes diagonal through my system, for instance. Oops, there we go. It's kind of hard to see. There it is. And I think those are the ones that I use mostly, right? There's a couple other ones, but again, you can. Well, one that actually is quite useful often is this intersection between 2 planes. Right, so if I wanted to have kind of the line where these 2 planes touch, then I can say, well, I want this one, and I want that one, then it has a line there. That can also be quite useful. All right, then points can be the same thing, but I'm not going to go through those. I don't. You can basically, wherever there's intersections, you can create points and so on and so on. All right, so with that, let's go from the work features all the way back here to the create area, and we're going to talk about these 3. And then we'll do some examples. Let's get a new one here. And let's start with the sweep command. So the sweep command, basically all it does is you create a 2D sketch and you give it a direction, and it kind of takes that and smears it along that edge. Not something I use a whole lot, I would have to say, but you should at least know that it exists. So let's start with some kind of a sketch. Doesn't really matter. Haven't done that in ellipse in a while, so maybe we'll start with an ellipse. There we go. So that would be our ellipse. And now we have to tell it the direction that we want to smear it in. Right? Should be something that's not parallel to this, otherwise it's just a single plane. So maybe what we want to do is, let's just draw onto one of the other planes here, make it easy. Draw it on there, and let's do a spline. We haven't done splines yet, so you have an example of how a spline looks like. Let's give ourselves some space here. And say finish. Now splines are, we can play with them, we can kind of shift around where they are and all that kind of stuff, but that's not what we're trying to do right here. So now we'd go back to sweep, and it already chose because there's only one option here. And then we need to tell it what it already chose the curve. Very good. And so it will smear it along this. Now you'll see that there's mainly two different options, right? The first one is that it changes the shape to be perpendicular to wherever your line is, or that it keeps it straight, right? And it will go along this, and you can see there's a whole bunch of extra options. But basically what it does is, well, it's assuming what it can't do is that first sharp turn here. So maybe we'll tell it to be straight up and down, and then it can do it. All right, so if I go look at this from the side, I get something like this. All right, so it's the shape it creates. Again, it's a cool feature. It's great that it can do this, but for most of what we're going to be doing in this class, we're going to have a lot of, straight lines and stuff. So this is not going to be something that comes up a whole lot. But again, it might, right? So you should at the very least know that this exists. All right, let's do loft then, which is kind of similar. Loft is something where it kind of transforms between different shapes, right? That's like the one that we did before was just a single type of shape. So let's start with a polygon of whatever size, the 6-sided one. And we'll say, okay, we'll finish the sketch. And so then we need to create ourselves a second sketch to get there. And so what we'll do is we'll do a plane, we'll do an offset. We'll do offset from one of our standard planes. And let's do 10. And then we can draw on this one. Where's it? New sketch. And maybe we'll do an 8-sided one. Oops. Keep on doing that. It doesn't have to be on the same level here. Or something like this. Right. So now I can say do the loft. It will ask from where to where. And there we go. All right. So it kind of creates a shape that goes from the 6-sided to the 8-sided, and it kind of creates lines and outlines to make this happen. Right? This can be useful, especially, and doesn't have to be different shapes. Right? You can use this to go from one to another. Also, you don't have to have this be on parallel planes, right? You can have this be turning as well. So we can say, let's create another work plane with another offset. Do another 5. Let's make this bigger. Do this one. Let's do one that's 10. Offset. And we'll just draw a line on this one. Not a spline, but a straight line, doesn't matter where. And then we're going to say we want to have a plane that is at an angle, like this one, angled around there, and choose whatever angle, doesn't matter. And now we can draw on this one. Where is our shape? Do it there. And then do another loft. All right, go from this shape to that shape. And there you go. You get a little, looks almost like a, zoom in. Looks a little bit like a telescope. Not really. Right, but you can create some pretty cool shapes with stuff. So that was the loft command. Questions about sweep or loft before we get to coil? No questions. Excellent. Then let's see. Let's create another part, and let's come to the coil command, which is also fun. But to do that, we have to draw ourselves a sketch first. So maybe we have to do this one right here. Let's do a circle like that, and then we need to have an axis as well. So I'll just do, let's see if it allows us to do it this way. We want to have basically this axis, and does it allow us to go through there? And great. Right, so it's basically the our standard axis here. And so we're going to go to coil, we're going to choose a shape. It already chose a shape because there's only one. And then we choose our axis. And maybe not. It's not 10 to begin with, let's say 5, and this is a little too small. Right, so you can see basically we choose a shape, we choose an axis that we want to rotate something around. So it's kind of like revolve, but it's revolve with a stretch to it. And so then we say we can do the pitch and how many times around. We can say how many times around and what the height is, right? Then that will what the overall height is, that will give us the pitch and height, and so on and so on. Right. So let's take with this one. So 5 revolutions, and maybe let's do 5. Core failure. Let's see. Could not build. Inputs for the coil resulted in a self-intersecting coil. Oops, should just hit the edit one. This one and axis. So let's get this pitch a little bigger. There we go. Right, and so this creates this very impressive looking coil, right, without really all that much work done. Right, so it's really quite a handy tool to do if you have anything that has a coil shape, instead of trying to do this with a whole bunch of sweep commands or loft commands or something like that. Right, so it gives us something very cool.
I have a question.
Yes.
Will we have to do the coils on the suspension of the truck?
No, we're not going to that detail.
Okay.
But you can use your coil for something else on the truck if you wanted to. Right. So the idea with the project basically is that I want you to try out as many of these features as possible. Right. I'm not going to go through and see which ones you used and which ones you didn't use, but the more of them you kind of use as you're playing around, the better. Just because then you've used them once, and if you at some point have to do something with this kind of shape, you'll be like, oh yeah, I remember. This is how, or at the very least, you remember that, yes, this is possible, right? If you remember, yes, this is possible, you can always go in and Google what the actual approach was, right? But at least you know that it is doable. All right, it's also within the coil. Let's do edit feature, right? What the last one that we saw was a spiral. So basically, instead of doing like this, we can also kind of go that way around. All right, so that would be something like this if we wanted to. Looks like the center part of an old electric stove. Right, so this would be kind of just fun little things to do, but we can actually use it for something that we've already talked about when we talked about screw fasteners, right? Threads and fasteners. We can actually now create something that is truly a thread. Let's do 20. And let's extrude it for 20 as well. All right, so you remember that when we started talking about screws and fasteners, we said that we have all kinds of different ways of doing it, of representing them, right? We could do the simplified ones, the symbolic ones, we could do the correct ones, and of course in Inventor we saw that we can also use that kind of surface treatment that kind of looks as if it was one, but it wasn't really, right? Because we couldn't see anything. But now with this coil, of course, we can say like, well, we can actually relatively easy. It's relatively easy to create something like this for us, right? So, and the way we could do that is we could basically create a coil, and instead of adding, we can subtract. Actually, we can might as well add as well, doesn't really matter. Depending on if we're, I guess, an inside or an outside. This would be outside, so we should probably add. And so what we can do is we can basically just add a coil that is has the right shape, and it will do it for us. So to do that, we basically have to, if we want to have a very simple one, we can basically cut a triangle through this entire thing. To do that, we'll have to have a sketch plane that is right out here. Our case, because we put it right there at one of our, either of our orange origin ones is going to work. So we can sketch onto there. And let's start down here, right? So we can do something, catches that edge line there. And let's do these at maybe, let's do 60 degrees. And let's do 3. And then do another one that is 3 and 60. And then we need to, so the tricky part, as Alberto said, you can't see the stuff because it's hidden, but we should at least grab the point. Should grab the point, just don't see that second. That line has an end, there we go. And with that, we should have a finished part there. And so then we can do the coil. Okay, did not draw that last line, so let's draw that again. Again, that's the tricky part with not seeing it, and I'll look up how to hide stuff. Now we should have a finished one, so we can do coil. I already found that one. And we need to create our axis. So let's go in here. We could do, I think it chooses the center one. All right, there we go. All right, now we finally have what we need. We don't want to spiral. Let's do pitch and revolution. And so we had this. This should be 3 high, right? So the pitch should be 3. Oops, we haven't selected our angle yet. Now we need to go in the other direction, so we can flip directions that way. And we want to cut. And then we can see it. We're not finished with it yet, but right, we get something that looks very much like that is actually a thread. And I've tested this out, right? So we can actually create pretty nice screws on the 3D printer. Next week on Tuesday, I can bring down those screws, right? That we just printed out, doing exactly this. Right now, remember that of course we don't want to have these very sharp corners up here and down there at the crest and the root, because those are failure points, right? So if we want to create this correctly, then we wouldn't want to cut out a triangle. We would want to cut out either round edges with a triangle or something else. But in general, if we want to do, we can create these relatively simple, right? So if we have something where we want to show that this is a thread, right? This might be actually a better way of doing it, because it's not that difficult to do, right? It took us maybe 5 minutes to create this, right? So overall, I think that's not too bad. Now, is there anything else in here? I think those were the things that I wanted to show you. So I think what we'll do is we will go and do some examples. And then once we've done those examples, then I'll let you work on the assignments. But let's get those examples over here first. There. So we need a new drawing, of course, a new part. Now we can see, just based on the numbers, that this has to be inches, right? There's no 0 here. So let's create a new one that is inches. So English, standard inch. and create. And now we're supposed to draw this part. And let's think about how to best create it. Right? I think there's two main ways, right? We can create this entire block and then cut stuff away to get here. Or we can create this sloped surface and then go from there. So I think it's easier to create the sloped surface first. So what we'll do is we'll create this, we'll draw this prism here, I guess. We'll extrude it and then we can add these two parts afterwards. So let's start with our first sketch. At the front, it is 0.63. Now, why do we have such a weird number? 0.63. Who can come up with a reason why we have such a weird number? We have that in multiple places, right? 0.63 here and over there. Why would we have that weird number? Anybody? What are we measuring this in? What's the units that we're using?
Inches.
Inches. Now, if you think about inches, if I tell you I want something that is 0.5 inches, what do I usually say? Do I say 0.5 inches?
Half an inch.
Half an inch. If I want 0.25, what do I say?
Quarter inch.
A quarter inch, and then we do eighths and twelfths and all that kind of stuff, right? And so if you think about this, the 6.3 is really 6.25, but it's been rounded. Right, and 6.25, of course, is what is that? 3/8, I think.
Yeah, I think so.
5/8, right? So that's why when you have inches, you often have these weird numbers because it's really a much longer number, but because this was given as 1 5/8 of an inch, right? On our drawing, it always gets written out as a decimal number, right? So that's why we have that here. You can see the same thing down here, right? So this is really 2.375, not 3/8. But that's just this side. All right, so how far in? 238. Extrude 238. There we go. That's our outline. And now we have to draw these shapes on here. Now, the tricky thing is if we just go on to here and say like, well, I'm going to create some shape, like, you know, this is not going to be accurate, of course, but if I just pretend that this will be accurate. But if I say, okay, I have this shape now and I'm going to extrude upward, then what is going to happen?
It's going to have the angle of the triangle on the bottom.
Exactly, right? It's going to look like this, which is not what we want to have, right? That's not what we're looking for. So let's get rid of this one. So what we can do is there's a couple different ways we could do this, right? We could just flip this over and draw on the bottom, which is flat. That's a little annoying because it's a little hard to see. And we want to practice our work planes a little bit. So what I suggest we do is we basically create a plane that's up here at the top end of our little extra blocks, and then we can extrude downward. And that's really easy, right? Because this plane up here is just going to be an offset of this plane down there. We're given the offset of 250 so that we can do that pretty easy. If we can get that bottom plane. There we go. And we want the, oops, we're no longer an offset. And we want the offset, in this case, would have to be minus 2.5 because we want that to go up. There we go. And now we can draw on this one, and we're all good. All right, so now we know basically what we have. We have a triangle shape that has a piece cut out, right? So the tricky part is that we can't just draw this first block here because we don't know how long this edge is. It's not given to us. It's basically a constructed edge. So what we'll do is we'll draw this overall shape and then we'll cut this out and then we can do the rest. So to do that, let's grab this corner right here and it goes a half in this one, so 0.5. Now I don't know the other ones there, so I'll start back here. This goes all the way over there, that's easy. And then it goes 1.75. Out to there, and then it connects back into here. Right, this is my overall shape. And then I'm just going to use some extra lines to kind of draw this in, right? So I know that I'm going to have a line that goes from here straight over to there. And I know what that distance is, 125. 1.25. Now I know where that is, and then I know the distance to the next block is 1, so I'll just draw myself an extra line here that has the length of 1. And then from there, I know I have to go straight across. And there's my second shape. And I can trim these away just for my personal entertainment. Otherwise, it doesn't really matter because they're not going to extend. And so I can go finish. I see these. I can do extrude. I can do both of them at the same time. I can either say go down a certain distance, or a little, if I want to be a little more elegant, I can say go down 2, and then I have to select another face, right there. And then I say okay. And with that, I just need to turn off the visibility. And this looks as if it's the right shape. Like I'm gonna get, I see this little gap here. All the lines look reasonable, so I think with this one we're done. Questions about this one? Yeah. All right, then let's do this one, which looks a little more complicated, and it is. This all looks like as if it were in millimeters. So let's go back to standard millimeters. Be careful not to use the sheet metal ones, right? Just a reminder to not do that. That will make your stuff look very strange. All right, so now what do we have here? Well, basically we have a cylinder, has a little hole in there, which is nice, and it's kind of has this edge cut off, and then kind of this notch built into it. Now, what's really tricky about this one, it's all very simple, except this number right here. Right, because this number right here is measured on the sloped plane, is not measured on any of the other planes. Right, so that's going to make it a little more difficult for us to do. But what I like to do with all of these is I like to do the things that I know to do first. All right, so obviously the first thing that we'll want to do is we'll want to create this big block. So that's, or the cylinder, not the big block. It's saying here that the diameter is 58. And that's what we all need. Extrude it. It's supposed to be 60 high. And with that, we have 90% of the mass. No, not quite 90%, but 80% of the mass is there. It's great. Of course, complexity, that's like the least is done. So next thing I think that's going to be relatively easy is going to be to create this hole right here. So let's do that. Again, I prefer just to draw circles and extrude, especially if they're just simple holes. So we will do a sketch up on here. That would be this end. We wanted a circle that has a diameter of 7. And it is supposed to be, so this would be the center of our big circle. And there's a 12 and a 9, so 21 from the center. Center of the circle, the center here. Ooh, that's close. 21. Good, we can finish, we can extrude. Go down, it says 20 deep. All right, so we have that feature done. Now what's left is figuring out how to do this slope. So what I would do, think the first thing, so usually if this notch were defined on something that's horizontal, right, then I would create the whole notch and then cut away the rest. But in this case, I think it's going to be, well, we'll have to cut away all this so that we can then find out where this edge is. So let's do that. For that, we'll need ourselves a nice, we'll use a plane that is an angle. To do that, we need to draw ourselves a sketch to have a line to turn around. Now, this line doesn't matter how long it is, right? Because we're not using it for it, just has to be nice and straight. And we know it is supposed to be, this will be kind of this is where we're kind of pivoting, right? So this will be 12 from the center. Dimension center of 12. And then we can say, okay, we can go to plane. And now this was going to be one of those where it's angled to a plane around an edge. We can take this plane is fine, and we want to angle it around there. And then we want to do kind of this right there. So that'd be minus 30. So that looks good. Now, what do we need to do? We need to now cut away everything here. The way we can do that cutting is we can do a little bit of a little trick kind of a thing, right? So basically we want to make sure that we cover this entire area that's supposed to be cut. So we can create ourselves a nice rectangle that covers the entire area. Say finish, and then we can say we want to extrude that. We want to do a cut, and we want to cut all the way down to that plane, right? Again, not giving a distance, but telling it where to cut to. All right, doesn't seem to be. Somehow doesn't like what we're doing. That's interesting. Maybe my let's see. Maybe my sketch is slightly off. Yes, you can see it's not right on that line. That's what the problem is. So let's see. Distance between these. Aha, there we go. Now we know what the problem is. All right, so this is something that you will notice, and it's not 100% consistent, but usually you can't use lines from other sketches. Right, so I was trying to get the line, this big rectangle here lined up with the line from this other sketch. But it didn't, and I can't see it, right? If I'm trying to do something here, I can't see the end of that point, right? Usually it will zip to that point, but it's not, right? So what we have to do is we have to basically grab that line and bring it here. Before we do that, let's move our rectangle out of the way so we can see what we're doing. Take that rectangle and select the base point and move it out of the way. Very good. Done. And now basically what we have to do, we have to grab this line from a different one and move it here. To do that, we use what's called project geometry. And so basically that takes whatever geometry we have and pulls it onto this plane. In our case, that's easy, it's just a line. And now we should be able to see the ends of those lines, which is perfect. So we can basically just do the dimension here to there, say 0. And finish, and now we should be able to do our say, choose this work plane and get cut, and it seems to be doing it correctly. There we go. Now we have our cutoff plane right here. So all that we're missing is this little notch. Right? Again, the problem is that we don't know what the horizontal distance is, right? We can't just draw onto this one and cut, because then it's going to cut diagonal in, right? We want to have it cut down there. So basically what we have to do, we have to create this line onto this work plane and then project it on something that is horizontal. So we can then draw it. All right, to do that, we know that this edge right here has to be 16 from the corner. So let's see if we can go onto this sketch, right? So we have to have something at 16 from there. To do that, again, we'll have to project this line up to where we are, just to show you. Right now, this line is on here as well. And so now we should be able to create a line. Again, this is just a construction line, so it doesn't really matter how long it is. And we have to dimension it with the end of my circle. It's not allowing me to do my end of my circle, so we'll just go from the center out there. And then we're going to trim this to the front, and then we have the point that we need. All right, so I have to dimension it with. So the end of this line to that line should be 16. Very good. And there we are. So now what we have to do is we have to go to the bottom of this, project this line down, create our rectangle, and we can do our cut. Now, some of this you will see take a whole bunch of steps in between to get to where we want to be. And one thing that I would highly discourage is, of course, that if we know what this length is, right? We know what this length is, we know what that angle is, we can figure out what what this length has to be. But I would strongly recommend against that, right? Because anything else that you change, that number is gonna not change when you move stuff around. So I would not do that. I would try to construct stuff as much as possible. All right, so now, again, we need a new sketch. And we need to get this line to be back onto our main area here. What happened there? Check geometry. Now, why is it not seeing it? All right, playing difficult. So we can just flip over there and flip back down there. There it is. Perfect. Now this you have to be careful. This looks as if this were now in my plane, but this dimension is not in my plane. It's kind of at an angle, so that's why it's still saying 16. But what we need is a rectangle, and let's do this rectangle here. Get that corner point all the way out to that. And we know how wide it's supposed to be. It's supposed to be 16 wide. 1/6. There we go. We can finish, and now we can extrude this part. We want to cut, and we want to cut all the way up to there. And okay, let's look from the top. That looks pretty good. All right, so let's get rid of all of our sketches that we no longer need. That sketch, we don't need the work plane. Again, I would not delete stuff, because sometimes when you delete stuff, you'll delete more than you want to. And you might need them later on if you want to expand this. All right, so this would be how we create this relatively simple looking object. Right? But just to be able to get this length here basically correct, right? It took us a fair amount of projection. Now, this is not to say that there's an easier way of doing it, right? I'm not claiming to have all the answers of the best approaches here, right? So if you guys come up with something better, just let me know. I'm always eager to learn. Questions about this one? Now, one thing that we could do if we wanted to check this, right, we can say, well, we kind of know what this length is supposed to be. So we can go to tools, we can go to measure, and we can measure how long this is, and this says it's 12.73. And so if you do your math, you'll see that that fits. So we're in good shape. Question about this example.
No.
All right, one more. One more that's crazy looking, and then I'll let you guys work on your own stuff. So this is again millimeters, right? Everything again millimeters, and create. Now this one, I have to say, the drawing is not correct. There is no way that this is correct, and the simple reason why I think it's not correct is that these, if you look at kind of this, the half circle here and the half circle there, because basically it's a slot, right? It is drawn as if this radius of 12.5 is in this sloped plane, right? Because it's connecting here, it's connecting there, so it looks very much as if it's in that plane. But it also says that the overall height has to be 25, which is not possible, right? Because 12.5 times 2 is 25. This would have to be higher if this was actually in the plane. So I'm going to assume that this drawing here is incorrect, that it's actually in the plane, which makes it a little easier to draw.
So you're assuming that it's not like diagonal, that it's vertical.
No, this whole the plane is going to be diagonal. That's very clear in the drawing. But I'm saying the way that they dimension these half circles, I think, is incorrect, right? Because they're dimensioned as if they were in the plane, in the sloped plane, right? But they can't be, this distance here can't be 12.5 if this distance is always also 12, is also 20, it's 25,
Yeah.
right? It says right here that this distance is 25. That means that this distance can't also be 25, right? And 2 times 12.5 would be 25. You see what I mean?
Yeah, yeah.
Right, so that can't be. And also, if you look at the center of this circle, coincides with this edge, which is supposed to be 25, and so that has to be, that doesn't work. Also, we'll see later on if we create this triangular hole here, that it would extend out to the edge here. So we'll have to fudge that a little bit. But nonetheless, this is kind of a fun shape to do. So what I would recommend to do with these kind of shapes is that we draw something that is vertical, expand it, all right, extrude it, and then we'll just cut the surface to look like this. And the reason why I would suggest that is that all the height measurements and everything is given as vertical heights, not heights within the plane. So it's going to be easier to do that. So let's grab ourselves something here, and we can start with this, which is of course the slot. Now we know that everything is symmetrical, so we can use the slot where it does the center point. So we can set this will be the center of our slot. We want it to be horizontal. Now it's supposed to be 60 in total, but if we're starting at the center, that'd be 30. And then of course we have to give it a 25 because we want to have the radius, the diameter. Right, again, if you're uncertain if you have the right, if you put in the radius or the diameter, you can always quickly check what the distance is between these two. Right, in our case, it says 25. That's exactly what we want, right? We said 12.5 and 12.5, right? The radius there and there. All right, so that will give us kind of the bottom round shape. And then we have to get this rest of the structure. Now, if we look at this, we can see it says 12 in 2 places. So I'm assuming that means here and on the other side. So let's start there. It starts right at the edge of the half curve. Fortunately for us, that's a point that Inventor grabs. And that is supposed to be 12. And then we need to go up here, 10 in 2 places. 10. And then go in of 6. And then from there up 35. 35, let's zoom. It says 24 across. Now we could just do this half and do everything mirrored, but I think this is going to be faster just to do this. And for some reason, doesn't like to draw this line. Oh, now it did. Interesting. Right. Tried this out yesterday, didn't like that line. All right, so when we go back out 6, go down to my line there, and then we'll add another one to make sure it's closed off. And with that, we can say our first sketch is finished. We can extrude. It said everything needs to be 90. And extrude both of these together. 90. All right. All right, so now we have this overall shape is ready to go. Then I think, well, I guess we could have done these holes at the same time, but let's do them now. So let's do the circle. So to do that, we need to sketch onto this side right here. The circle is supposed to have a diameter of 20. It should be in the right location, but let's double check. All right, so this should be 25 above. It is. And if it's in the center, should be over to the sides too. Well, it's on the center, we can see it. All right, that's 1. Let's extrude that through. Got our main hole, and then our little triangular shaped hole. Now that line is supposed to be, the bottom is supposed to be 12 side to side. So what I suggest we do, we draw ourselves a line that is halfway, so 6. And then we draw a line, we don't know how long this is, but we know it has to go up there. And then we dimension stuff to make sure it's the right size, and then we'll finish that triangle. So we know the bottom of the triangle is this line. It's 45 from the bottom, so we know this has to be 45, a little high. And we know that top to bottom is 15. Now it's very important to remember that we're drawing this on the straight surface, right? If you had cut this in first, then any distance that we were drawing on this would have to be longer, right? That's why we want to do this first. All right, we'll finish that. Again, we could mirror, but I think for a lot of these things, it's just faster to draw 2 lines. Finish. Extrude. Again, we'll do the cut. And there we go. Now, again, we'll notice later that that cut is going to extend. And I was looking at this figure, but can't see anywhere where it says that this hole does not go all the way through. Right? If this was not going through, there would have to be some kind of note saying it doesn't go through, but there isn't any. All right, so what we'll do is we'll create this cut. The way we'll do it again is we'll create ourselves a work plane, and then we'll cut everything down to the work plane. So plane, we need an angled plane because we're giving the angle. We want to have this plane going around that angle. Can't quite grab it. There we go. We want it to be something like this, in this direction. Again, minus 30. It's good. And then we'll sketch on this one. It looks like we can maybe grab that line. Let's see. Create ourselves another rectangle. Right? So we could create this exact same shape and then cut it. Or we can just do a rectangle. Now, can we? Seems that it can grab that line, so we put it all the way up to there. Finish. Extrude. Extrude to there. And okay. And with that, we kind of see we have the right front shape. Now, also, it looks like this is not even a hole. Now, come to think of it, right? There's nothing. Should have Well, maybe it's just the way it's drawn, I guess. Should be some kind of shading to show that this is a hole. All right, so we have all this. That means still need to do this back cut here. So let's see. So actually, before we do that, let's turn this plane off. We definitely don't need that anymore. So let's do a new sketch. Let's bring this in. So we basically need to cut away this piece right here. Now, how big is that piece? From that edge to that edge is 15. I know that one is 10. So we 25 all the way down is 50. Total is 20. So we need is 70. So we need something that goes down 20. I guess we could just do a rectangle instead. We know that we want to go how far in? 32. It says right there. In this direction. 32, and we said in this direction 20. Finish. And then we can extrude this guy as a cut all the way across. However long. Interesting. Didn't get our rectangle correct for some reason. All right, it's slightly too low somehow. Let's see. Means we didn't hit that top edge again. You know what we'll do? Let's make it a little faster. We'll just say get rid of this whole thing. Delete, and then we'll say you can get rid of the sketch as well. We'll just do it again. All right, otherwise we'd have to play around for too long. So that means we didn't hit that edge correctly, so it was not projecting through. So let's make sure both those edges are projecting through, and now grab our rectangle here. And we said it was 32 and 20. And now we'll do the extrude. And now it's working. And now you can see what I'm saying is that we get these weird, we get basically the end of this cut back here, which we shouldn't be getting based on this drawing. So that's a little annoying. I think what we'll do is we'll just basically close this off in the end here. So we'll just do a sketch here. Seems to be getting that edge though. It's very interesting. Let's make it double sure. A rectangle here to here to there. How far down doesn't really matter. And now that was supposed to be 24 across, so we can extrude that. 4 correction, and now cut. All right, with that, we've closed it off. Then the only things that are left are putting in the rounds and the fillets and the holes. So let's do that. Now, before we do the rounds and the fillets, let's do the hole first, so it's easier to measure where it is. So we need to sketch onto there. Circle is supposed to be 12. We can do it on the halfway, so one less measurement. 12, and then the distance is supposed to be 12 in this. What is this distance? Oh, 12, there it is. 12 from that edge. Some of these are a little hard to see. 12. Finish, we'll assume, because it doesn't say anything else, that this hole goes all the way through. And then all that's left is the fillets. It says fillets and rounds all 3 millimeters. So choose this one. Here we have to choose 2 because we have that cut and there. And okay. And with that, I think we look pretty good with those little extra pieces that we did. Questions about this one? So if I were the manufacturer, I would send this right back to whoever sent me this and have them fix or explain to me why the drawing doesn't fit to the measurements and things, right? Kind of fix what this is and why that slot that we cut through that notch is not showing up in the end there, right? Give me a little more details. But also we would never give somebody something like this, right? We give orthographic projections. This is just, you know, to start out with. All right, so no questions. I also see no camera, so it makes it a little difficult to see what you're doing. If there aren't any, then let's switch over to your assignments. We have another 3. If I can get this to, there we go. We have this one right here. This is a candidate for creating a work plane that kind of is in this, that kind of creates this angled cut, right? You can basically define yourself this point and that point and that point, and then create a plane and then cut down to that plane. My suggestion, that would be the first one. The second one is this right here. This one I don't think you necessarily need to create this. You probably want to create a plane up here to make this cut. Very important here is that this roof structure, if I remember correctly, is not symmetric. Right, so it says from there to the gable, right to the top of the gable is 20, and if we look from the other side, we get 30, so 55 minus 90 is not 20, right? So it's going to be slightly different. All right, then the third one is this block right here. The important things to realize for this one is that this hole is going straight down, right? It's not going at the angle of this surface. But the measurement is in the surface, right? So this distance is on the sloped surface, not on the flat surface. So you will have to create that surface to figure out where this point is. That is that one, and the last one is right here. Now this is one that is the poster child of being symmetric, right? So I would just draw basically half of this, everything except the hole, right? But you can kind of just do half of this and then mirror everything over to the other side. Some things to point out. So it says there's the one that says, like, the note that you have right here, that this slot right here, it's kind of cut in the middle, is 12 deep from the center line, right? So when you go from the center line, right? So it'll be either 12 deep. Well, it's kind of confused me there for a second, right? The deep one is, so it's measured from the center line, right? So from that center line would be a height, not a depth. So that's why I got kind of confused there for a second, right? But so this distance here is basically whatever the overall diameter is the radius is 20, so be 20 minus 12 is 18, would be this, right? But you can measure it from the bottom up as well.
I have a question.
Yeah.
What's that 10 for then?
The 10, that's a good question. Oh, because it's the wrong one. See, thank you for that question. I was looking at the wrong way. This depth here for the bottom one, that's why it's deep. Now it all makes sense. This is the one that I did not redraw this time. So you're right, this is the 10 is for up here, the 12 is for the bottom part. Right, it's hard to see, but the distance that would be going downward for that cut right there. And I'm thinking it's the same over on this one. No, it's not, because it says 15 in 4 places. So this is a little bit of a complex one to do. So be very careful that this, although it might look the same, but this height is not the same as that height. that make sense? It will be once you
Yeah.
start on.
I already finished them,
Okay.
but I didn't did that correct. So I was wondering if
Okay.
maybe I can do it later because like we have a test today. So I was wondering if maybe I could use this time to finish studying.
If you want to do those later, that's fine by me.
Okay,
Everybody's taking the same test, or
most of us.
okay,
Yes,
so
me too.
so people who want to do that, you are free to do so. Just one little step. Oh, actually, no, actually, I will be around. I was gonna say I probably won't be active on Monday, but I will be because I don't travel until the evening. So yeah, however, I would, especially with this one, I would give myself a little time to do.
Yeah, like I basically have it finished, but I just have to change that little part at the bottom.
Yeah.
Yeah.
I'm just saying for other people who may want to step out to study.
Okay, thank you then.
Yeah.
See you next week.
See you next week.
Thank you. See you.
Are you also going to study? Is that what you're
Yeah,
saying?
we have a statistics exam.
Statistics is nothing. It's easy.
No, it's pretty awful.
Statistics is always difficult. It's a fairly dry topic usually. So.
I'm
All
also
right.
going to study, Professor.
Okay.
Thank
Enjoy.
you.
Good luck with the test.
Thank you, Professor.
Thank you.
Yes,
Well,
so do I.
I have
Thank
a
you.
question. So
Thank you.
on
Yeah,
Tuesday you'll be here, right?
I will be face to face. Yes, and I
And
hope there too.
you'll be here for the rest of the semester
No, but
for a week.
for 4 weeks.
Ah, okay.
And
Okay,
for
great.
a little bit of a
Nice.
trip, 4 weeks for 1 week. Yeah, but I'll be there for. Fortunately, I will be there through the next exam and the beginning of the project, so that's kind of nice.
Okay, great. And we were wondering about the next exam. It's going to be like an Inventor, but face to face. Yeah.
Well, we'll have to discuss that. Depending on how people. If everybody's using their laptops, no, probably face to face is still better because it's easier for me to answer questions that way. But we'll discuss that once we get there because we're still a little bit away from that exam.
Okay. Yeah, I want to see how that goes because I take my time doing these like figures, but we'll see.
Well, we can discuss how we want to run that exam. It is not going to be as annoyingly complex as this one. I can tell you that.
Oh, and
Sure.
anyways, if you're there, I think it's better. Like we'll ask you questions if I get stuck. And, like,
Exactly. Well, you should do that for your homework assignments too, right? If you get stuck, just
yeah.
send me a quick email and say like, hey, here's a screenshot of how far I am. How do I get to the next point?
Okay. Thank you, Professor. I will also be studying for the exam. So.
Why did you guys study beforehand? What would you have done if I had just been like, oh, today is a full class of lecture?
No, not study. No, obviously not studying. I already studied, but I want to review my formulas and make sure I have
All right.
the top of it. Thank you, Dr. Carl. Have a good
Good luck. Yeah. You can.
Whether I have a question.
Yes.